Hello, now in this video I will solve all the gate question asked in the linear algebra. This is the linear algebra. I will cover the questions from 1994 to 2013. So I will cover all the questions asked in this category, means linear algebra, in the gate exam, and I will explain you the solution of each questions. Now this is the question of the 1994. You are required to find out this statement is true or not. Rank of the matrix this is 3. How can you solve? Means find out the rank of this, or find out it's true or not. Its rank is 3. This is the question of 1994 gate exam. To solve the problem, you find out the rank of the matrix. So to find out the rank, you need to find out the determinant values of this matrix. So this is the determinant value of this matrix. To make a further zero, to make more number of zero, you perform in R2 plus R3. This means it is equal to 0 0 minus 7 and 6 2 4. It will remain the 4 0, and 8 minus 4 is 4, so 4 and minus 4. So minus 7 into the determinant of this 2 4, you will get 2 into 4 is 8, this 8, so minus 7 into 0, so it will 0. So rank, so determinant value is 0. This means rank is not equal to 3. It should be less than 3. 2. Take the 2 by 2 determinant here. Take anyone. This, suppose this row 4. So this into the 8 into 0 is 0, and 4 into minus 4 is not 0. So rank is 2. So the rank is 2. So rank is not equal to 3. So the solution of this matrix is rank is 2. It is not equal to 3. So this is the false statement. This is another question asked in 1994. You are required to find out the eigenvalues and eigenvectors. For any one eigenvalue, find out the corresponding eigenvector. Means this is a 3 by 3, so maximum lambda will be 3, lambda 1, lambda 2, lambda 3. Find out, and for one lambda you get the one eigenvectors. So to find out the eigenvalues, I will just reduce minus lambda in 1 3 4, and determinant L will be equal to 0. So this is a characteristic equation. You have to solve this matrix to find out the values of lambda, means eigenvalues. This is equal to 1 minus lambda into, multiply this into this, and minus 2. Okay, it will come as lambda square minus 7 lambda and plus 12 minus 2. This is equal to 0. This means if you solve this, you will find out this is lambda square minus 7 lambda plus 10. So you can minus 7 you can write is minus 5 minus 2. So it will come as ultimately lambda minus 5 and lambda minus 2 is equal to 0. This means lambda is equal to 1 5 2. So 1 5 2 are the eigenvalues, and suppose I want to find out the one. The question was asked is for any one of the eigenvalue find out the corresponding eigenvectors. So I am choosing first lambda is equal to 1, and I will find out the eigenvectors for corresponding matrix. So I will put in this 1. So it will become 1. It will become 2. It will become 3. So lambda is equal to 1 5 2. Put for one value of eigenvalues 1. I will find out the eigenvectors, means a minus lambda I into x. X means x, y, z is equal to 0, 0, 0. To solve this, I'm putting 1, so it will become 0, 0, 0, 2, 3 minus 1, 2, 1, 0, 2, 4 minus 1, 3 into x, y, z is equal to 0, 0, 0. This means solving from 0, I will not get any equation from this. 2x plus 2y plus z is equal to 0, and 2y plus 3z is equal to 0. So from subtracting this equation from this equation, I will get 2x minus 2z is equal to 0. This means x is equal to z. This is the first condition. X and z are same, so 2x plus z means 3x. 3x, suppose I need to find out the values of y, so 2y, so y is equal to 2y is equal to 3z, 3z, 2y is equal to minus 3z. So suppose z is k, so x will be k and y will be minus 3 by 2k. So I can write x, y, z as k times 1, y is minus 3 by 2 and z is 1. If I multiply all this with 2, it's k dash into 2 minus 3, 2. So this is the eigenvectors 2 minus 3, 2 for lambda is equal to 1. This is the question asked in 1996. You are required to find out the eigenvalues of this. To find out the eigenvalues, I will just reduce minus lambda in the diagonal element and find out the determinant value and make it a determinant is equal to 0. This is the characteristic equation. I need to solve this characteristic equation to find out the eigenvalues. So this is equal to, this means 1 minus lambda into 1 minus lambda to the power whole square minus 1 plus minus 1 into for this, reduce this and this, and my 1 minus lambda means 1 minus lambda minus 1 minus plus 1 into this, plus 1 into 1 in minus this means 1 minus 1 plus lambda is equal to 0. So you will get 1 minus lambda is common, 1 minus lambda into, and a square minus b square, you follow this rule. 1 minus lambda minus 1 means minus lambda into 1 minus lambda plus 1 means 2 minus lambda, and here 1 minus 1 0 and minus lambda into minus 1 is equal to means plus lambda, and 1 minus 1 0 plus lambda. So what is the meaning of this? This is equal to 1 minus lambda 2 minus lambda plus 2 lambda. This means take lambda as common, lambda into 2 minus 1 minus lambda into 2 minus lambda equal to 0. This means lambda into, when you solve this, it will be 3 lambda minus lambda square is equal to 0. So you will get lambda into 3 minus lambda is equal to 0. So lambda will be equal to 0, 0 and 3. So the solution for this is 0, 0, 3. So C is the solution. Another easy value is to find out the eigenvalue. For sum is 3. So sum of the eigenvalue will be 3. So in this option, you see that there is only two options, this and this. So one of the answers will be from C. And transpose of this matrix is not the orthogonal matrix, because when you multiply A and A dash, you will 1 into 1 into 1 into 1 plus 1 into 1 plus 1 into 1 means 3. All the element will become 3. So 3 is a factor. So this, what is the meaning of this? This is not an orthogonal matrix. So if suppose this is the solution, then if 1 is the eigenvalues, then 1 by lambda is also the eigenvalues, means 1 by lambda. But it will happen only if this is the orthogonal matrix. But this is not the orthogonal matrix, so this solution will not be correct. So the correct solution is out of this two option, this remains. So this is the solution. This is the easy way, but you go through by this method. You just find out the lambda by solving this equation. This is the 1997 question. For the following set of simultaneous equation, I require to find out whether the solution is unique or no solution exists, or this is. So I have already explained how to check this, whether any solution exists or not. You need to find out the determinant values of A and K, and if rank of A is 3, then definitely there is unique solution. So you can write it in simplified way by multiplying it with 2. 3x minus 2y is equal to 4. This is the simplified form of the equation. To check the consistency, find out the rank of A and K. So A is matrix of coefficient. So 3 minus 2, 0, 4, 2, 3 and 7, 1, 5. Find out the rank of this matrix. How can you find? You just find out the determinant values. 3 minus 2, 0, 4, 2, 3, 7, 1, 5. This means, first of all, 3. I am expanding the first row. 3 into 10 minus 3 minus 2 into 21 minus 20. This is equal to 10 minus 17. This is equal to 21 minus 2, 19, which is not equal to 0, because the determinant value is not 0. So rank is 3. Rank is 3. So if rank is 3, then equation will have unique. So for this 1997 question, the answer is, the solution is unique because rank of matrix A is 3. Now come to the first question of 1999, which is required to rank of the matrix you are required to find out the solution. You are required to find out the rank of this matrix. How can you find the rank? See, to find out the rank, you find out the determinant value of 3 by 3. If it is not equal to 0, then the rank will be 3. But if you can also transform the row in such a way that you will get the maximum number of 0, so that you can find the determinant value easily. So how can you find out this? See, the determinant value, to find out the determinant value of this, there is some easy process. You multiply r2 to r2 plus r3. What you will get? Minus 6 plus 12, minus 12 plus 12, minus 8 plus 8, minus 36 sorry 36 minus 36. So all row becomes 0 in this. Similarly, for r2, perform in r2 following action: r1 twice r1, in r2 do twice r1 plus r2. What will you see here? 3 into 2 6, minus 6 0, 2 into 2 4, minus 4 0, minus 9 into 2 minus 18 plus 18 0. So both row are 0. So you can write it as 3 2 minus 9 0 0 0 0 0 0. So this is the same equal. So rank, here you see the two rows are 0 only, so rank is 1. Rank is equal to 1. So in this, rank of the matrix is 1A. This is the 1999 question. The eigenvalues of the matrix, you have to find the eigenvalues. So the method by which you can find the eigenvalues is just reduce and minus lambda. Just reduce lambda in the diagonal element and find and make the determinant is equal to 0. So this is the characteristic equation. When you expand this, it will come as lambda square minus 2 lambda minus 24 into 0, and you can expand in this 2 as a minus 6 lambda plus 4 lambda, and you will get lambda minus 6 into lambda plus 4 is equal to 0. So lambda is equal to 6 and minus 4. So there is two eigenvalues, 6 and minus 4. 6 and minus 4. So A and D is the solution. This is the question of 2000. The three characteristic root of the following. So three characteristic roots means eigenvalues. You are required to find out the eigenvalue of this matrix. Process is same as previous. 1 minus lambda, 2 minus lambda, and 2 minus lambda, and determinant is equal to 0. You are required to solve this characteristic equation. So the solution will be 2 minus lambda into 2 minus lambda into 1 minus lambda is equal to 0. This means lambda is equal to 2 2 1 1 1 2. So in this 1 2 2, this is the solution B, because lambda is equal to 1 2 2. So this is the correct solution B. This is the 2001 question. X plus 2y is equal to 2 and 2x plus 2y is equal to 5. Here you can, if you transfer this to here, x plus y is equal to 2.5. So the two lines says the different word, x plus y is equal to 2 and x plus y is equal to 2.5. So definitely there is no solution. There is no solution. B is the correct answer. Here is another question of 2001. The rank of a 3 into 3 matrix is found by multiplying non-zero column matrix A and of size 3 and non-zero row matrix B of size 1 into 3. So you are required to find out the rank of any matrix non-zero. So suppose A is the matrix, column matrix, x1 y1 z1 is the element, and B is another row matrix, x2 y2 z2 is the element of B. So multiplying A and B, If you multiply a and b, you will get x1, x2, x1, y2, x1, z2, and similarly you will get this matrix. So check whether determinant is 0 or not. If you make the determinant of this, you will find out that y1, y2 multiplying z1, z2 minus multiplying this 2 will become 0. Similarly, any two column you multiply, you will get the 0. Multiply y1 x2 into z1 z2 minus y1 z2 into z1 x2 is equal to 0. And for this, y1 x2 into z1 y2 minus z1 x2 minus y1 y2 is equal to 0. So definitely rank is not 3. Rank is not 3. Also, rank is also not 2. Rank is not 2 because for any two selected 2 row and 2 column, multiplication across this will always be 0. x1 y2 into y1 z2 minus y1 y2 into x1 z2 is equal to 0. So definitely rank is not 2. So come to the single level x1 x2. So this is now not 0, so rank is equal to 1. Rank is equal to 1. So rank of this matrix C is 1. B is the correct answer. This is a 2002 question. The following set of equation has you are required to find out a consistency of this equation. So make them two matrix A and K and find out the rank. So here you see the coefficient matrix A is this, and the determinant value is equal to 3 1 minus 2 2 minus 1 0 1 1 2. Make in C1 perform C1 plus C3. You want to make maximum number of 0. This means equal to 4 2 0 2 minus 1 0 1 1 2. So it is equal to 0 0 and this across 2 into 4 into 4 minus 4 and 2 into 4 minus 4. This means minus 8 minus 16, which is not equal to 0. So rank of A is 3. So the solution is rank of A is 3 and it is equal to the rank of K. K rank will also be 3 and it is equal to the number of variables. 3 is the same as number of variables, so the solution is unique. So this has a unique solution. B is the correct answer. This is a 2006 question. Eigenvalue of the matrix X are 5 and 1. What are the eigenvalues of matrix S square? So you know very well that if the eigenvalues are lambda 1 lambda 2, then the square of the matrix will have eigenvalue lambda 1 square lambda 2 square. So 5 square is 25 and 1 square is 1. So 25 and 1 are the eigenvalues of S square. So 1 and 25. A is the correct answer. This is another question of 2006. This is a 2006 question. What is this? E is this multiplication of matrix E and F is G. Matrix E and G are E and F is equal to G, means result should be this E and F. So multiply each item. You will check whether G is make the first row vertical, means cos, then minus sign and 0. So cos square x plus sin square x is equal to should be 1. So here is a minus sign, so it should be plus, means minus cos. First is cos, second is minus sign. So see, cos and minus sign, this is the cos minus sin 0. If you multiply cos into cos square x minus sin theta into minus sin theta sin square theta, so cos square theta plus sin square theta is equal to 1, 0 into 0. So it is 1, and multiply this. Cos theta into sin theta minus sin theta into cos theta is equal to 0. So the next is 0, and third is cos theta into 0 plus minus sin theta into 0 plus 0 into 1, so 0, so 0. So this is the only, so C is the correct answer. You can see first row following the rule. In this question you should know how to multiply the matrix. Make the row vertical and multiply each of the column element. This is the second 2003 question. You are required to find out whether consistency of these equations. The process is same. You make the two matrix A coefficient of this and K coefficient including this column, and find out the rank of A and K. So the determinant of A is this. If you perform in R1 minus R3, what will happen? 0 1 0 2 1 2 1 1 1. So for expanding this first row, 1 into 1 minus 1 into 2 minus 2 into 1, this is equal to 0. So determinant of A is 0. If you take 2 into 2, suppose I am taking this 2 1 1 2, and determinant is 4 minus 1 3. So rank is not 3, but rank of A is 2. Now you are required to find out the rank of K matrix. So the K matrix is this. You are required to find out the rank of K. Take this 3 column. So and find out the determinant, means 2 1 1 1 2 1 6 6 5 6 6 5. Okay. Reducing this means performing in R1 minus R2, I will get 1 minus 1 0 1 2 6 1 1 5, and adding this to this column. So it will be equal to 1 1 1 0 3 2 and 0 6 5. So determinant is equal to 1 into 15 minus 12 3, which is not is equal to 0. So rank of K is equal to 3. So rank of which is not equal to rank of A, means A is 3, which is 2. Rank of A is 2. So if the rank of K and rank of A is not same, then you will get no solution. That means the system has no solution, means C is the correct answer. This is a 2004 question. The sum of the eigenvalue of the matrix. This is very easy. Sum of the eigenvalues is always equal to the trace. And what is the trace? Trace is the sum of the leading element of the diagonals. Means 5 plus 1 plus 1. 1 plus 5 plus 1 is equal to 7. So sum of the eigenvalue will be 7. This is so B is the correct answer. This is another question of 2004. For which value of x will be the matrix given below become singular? Singular matrix means determinant is equal to 0. So find out the determinant and make it equal to 0 and solve the determinant for values of x. So in this column I am expanding across this 2. So it is equal to 2 into, remove this column and remove this row and remove this column. What remains here is this 2 into opposite of this 12x minus 8 into 6 848 is equal to 0. This means x is equal to 48 by 12, which is equal to 4. So x is 4. So x is 4. So A is the correct answer. This is the 2005 question. Which one of the following is an eigenvectors of the matrix? Eigenvectors. To find out the eigenvectors, you first need to find out the eigenvalues, and you can find out the eigenvalues by reducing lambda in all the diagonal elements and determinant, and make the determinant is equal to 0. So remember one rule. So this is not the upper triangular matrix, so you cannot solve easily. Here the rule is that 5 minus lambda into the determinant of this, and determinant of this will be equal to 5 minus lambda into determinant of this. This means 5 minus lambda into 5 minus lambda into, because all the elements are 0, determinant of this 2 minus 1 and this. So it is equal to 2 minus lambda into 1 minus lambda minus 3 equal to 0. This means 5 minus lambda into 5 minus lambda, and if you solve this, you will get lambda square minus 3 lambda minus 1 is equal to 0. Here lambda value, one lambda value is 5, 0. Lambda is equal to 5. So A is this matrix. To find out the eigenvectors, A minus lambda I into, here is the 4 by 4, so x, y, z, p, suppose there are 4 variables, is equal to 0 0 0 0 0 matrix. So for lambda is equal to 5, I will put 5 minus 5, 5 minus 5, 0. So A minus lambda I will be 1 2 3 4 1 2 3 4 0, and the rest will be 2 minus 5 means minus 3, minus 3 1 and 3, and 1 minus 5 means minus 4, and rest element is 0, and x, y, z, p is equal to 0. So from third, and because this will get no solution, this will get no solution, and for this 0 0 3 1, make it vertical and multiply each element. What I will get, minus 3z plus p is equal to 0, and for this 3z minus 4p is equal to 0. So adding these two equation, I will get z is equal to 0 and p is also is equal to 0, because z is 0, so p is 0. So the last two element is always 0. Last two element is 0, and x, y can be anything. Let's check which eigenvectors is following this. Last two value is 0 and upper two is can be anything. So A is the correct answer. This is a 2007 question. The number of linearly independent eigenvalues of this is what? You first remember one formula, that a number of linearly independent eigenvectors is always equal to the rank of the matrix. So here rank of this matrix is rank. So determinant value is not 0, because 2 into 2 is 4. So determinant value is not 0. So rank is 2. So Number of linear independent eigenvectors is rank of the matrix, and rank of the matrix is 2, so the correct answer is C, 2. It is a 2. This is another example question of 2007. If a square matrix A is real and symmetric, then the eigenvalues are always real positive. What is this? So you can check out this formula by uh, just taking one example matrix and do this. Here is the example. A is a matrix. This is a symmetric matrix. So the eigenvalues are 0 and 3. So it is a real. If a square matrix is real and symmetric real, it is also real symmetric, then the eigenvalues are always real. So A is the correct answer. Because one of the eigenvectors is 0, so you cannot say always real or positive or negative. It can be positive, negative, both. So A is the correct answer. This is a 2008 problem. The matrix has one eigenvalue 3. The sum of the other two eigenvalues is, sum of the eigenvalues is equal to the sum of the leading elements. So 1 plus p is equal to 3 plus lambda 1 plus lambda 2. So lambda 1 plus lambda 2 is equal to 1 plus p minus 3. So p minus 2 is the correct answer. C is the correct answer. This is another 2008 question. For what value of A, if any of the following system is XYZ having a solution, you are required to find the values of A. First, the rule is that you have to find out the rank of the two matrices A and K. Here is the determinant value of A. When performing in R1 minus R2 minus R3, I will get 0 0 0 1 1 1 1 2 minus 1. So the first row is 0, so rank of A is for this 22 minus 1 2 minus 1 1, so rank is not 3, but the rank of A is 2. And for that, so for the solution to happen, rank of K matrix should also be 2. So K is this matrix, and you are required to put A in such a way that rank is 2. This means take this 3 column and find out the determinant value. 3 1 2 0 1 minus 1 4 4 A is should be 0, then only the rank will be 2. Now perform in R3 add R2. So 3 0 4 1 1 4 3 0 A plus 4 is equal to 0. This means there is 2 0, and take across this 1 into 3 3 4 and A plus 4 is equal to 0. This means 3A plus 12 minus 12 is equal to 0. This means 3A is equal to 0. This means A is equal to 0. So A should be 0, then only you will get the any solution. So A should be equal to 0. So B is the correct answer. This is another question of 2008. The eigenvectors of matrix are written in the form of 1 by A plus 1 by B. What is the A plus B? So the eigenvectors, you are required to find out the eigenvectors. To find out the eigenvectors, you first need to find out the eigenvalues. And to eigenvalues, how can you calculate? 1 minus lambda, 2 minus lambda, and determinant is equal to 0. So the determinant is 1 minus lambda 2 0, 2 minus lambda is equal to 0. This means 1 minus lambda into 2 minus lambda is equal to 0. So lambda is equal to 1 2. So there is two values of lambda, and I require to find out the eigenvectors for each values of lambda. Now A is this matrix and lambda is 1 and 2. Solve A minus lambda I into x is equal to 0 to find out the eigenvectors. So first I will put 1 as a lambda. So 1 minus 1 is 0. So 0, 2, 0, 1. 2 minus 1 is 1. And x, y is equal to 0. The meaning of this is 0 into x, 2 into y, y is equal to 0. And from second equation, 0 into x, 1 into y, y is equal to 0. Both equation gives y is equal to 0 and x can be anything, suppose k. So eigenvectors will be x, y is equal to k into x is 1, 0. So 1, 0 is the eigenvectors. So it is in the form of 1 a. That means a is equal to 0. Now for the second values of lambda, second value of lambda is 2 and put a minus this 1 minus lambda is 1 minus 2 means minus 1. So 1 minus 1 and 2 is 0, 2 0 0, 2 0 0 into x y is equal to 0. This means minus x plus 2y is equal to 0. So if y is equal to k, x will be 2k. So x y will be equal to k times 2 1. So I need to, so 2 1 is the vector form, means equal to k by 2 into 1 1 by 2. So this is the format. This vector is the second vector. So 1, it is equal to 1 1 by 2 is equal to 1 b. So b is equal to 1 by 2 and a is equal to 0. So a plus b is equal to 1 by 2. So here the a plus 1 plus b is b. 1 by b is the correct answer. This is a 2009 question for a matrix M. The transpose matrix is equal to inverse of the matrix, means transpose is equal to inverse of the matrix. The values of x is given by transpose is equal to inverse of 2 by 2. That means determinant values is equal to 1. Then only it will be possible. So find to make the determinant value of this matrix is equal to 1 and solve the determinant for values of x. So this is the equation. Determinant value is equal to 1. That means 9 by 25 minus 4x by 5 is equal to 1. X will be equal to minus 16 by 20 is equal to minus 4 by 5. So minus 4 by 5. So A is the correct answer. This is a 2010 question. One of the eigenvalues of matrix A is this. So to find out the eigenvectors, you first need to find out the eigenvalues, and the procedure of finding the eigenvalue is same. So put lambda in the diagonal elements and determinant is equal to 0. Solving this, it is this means lambda squared minus 5 lambda plus 4 is equal to 0. Minus 5 lambda, you can write it as minus 4 lambda minus 1 lambda. So it will give lambda minus 4 into lambda minus 1 is equal to 0. So lambda can be 1 or 4. Lambda 1 is equal to 1, lambda 2 is equal to 4. So the first eigenvectors can be calculated by lambda is equal to 1, and the second eigenvectors can be calculated by putting lambda is equal to 4. So I am first trying to find out the first eigenvectors by lambda is equal to 1. So a minus lambda I multiplied by xy is 0 0. So a minus lambda, lambda is equal to 1. So when you put lambda is equal to 1 in this, 2 minus 1 is 1, 3 minus 1 is 2. So this a minus lambda will be this, and x y is equal to 0 0. Solving the first equation, x plus 2y is equal to 0. This means if x is equal to minus 2y, suppose if y is equal to k, x will be minus 2k. So x y is equal to k times minus 2 into 1. See the option is this. So this can be obtained by multiplying minus 1. You multiply it with minus 1 equals to minus k into 2 and minus 1. So eigenvectors is 2 minus 1 is the eigenvector. So the answer is A. This is the 2011 questions, and problem is same. You are required to find out the consistency of the equations. Here in this equation you see that um, the constant of the right side is 0. That means rank of A will be equal to the rank of K. So you are required to find out the rank of A. If the rank of A is 3, then it will be have a unique solution. If it is less than 3, then there will be infinite number of solution. So I will try to find out the rank of matrix A. This is the matrix A. Now you are required to find out the A. So A is this determinant. So multiply this row with 2 and subtract it from row 1, means 2 minus 2 0 0 0 sorry 2 0 yeah 0 and 1 1 here is 2, 1 minus 2 is minus 1 and 1 and 1 minus 1 and 1 0. So in this I am taking this column, expanding it through this column. So 0 and for 1 into 1 is 1, minus 1 into minus 1 is 1, minus 1 into 1 is 1, so 0. That means determinant value is 0. Determinant value of A is 0. That means, and rank of A is, suppose I am taking this 2 row, this 2 row and 2 column. So if I want to take the determinant, it will becomes as 2. So rank of A is 2, which is less than 3, and 3 is the number of variables. So rank of A is 2, which is smaller than the number of variables. So there is infinite number of solution. So in this question, the answer is infinite number of solutions. This is the 2012 question. For the matrix A, one of the normalized eigenvectors is given as this. So here again the question is about eigenvectors. To find out the eigenvector, you first need to find out the eigenvalues. So it is a 2 by 2 matrix, so the number of eigenvalues is 2, and procedure is same. Reduce the lambda in the diagonal element and determinant is equal to 0. This is the characteristic equation. This means lambda square minus 8 lambda plus 12 is equal to 0, and lambda minus 6 lambda minus 2 is equal to 0. So lambda is equal to 2 and 6. So put the lambda. So characteristic equation is for the eigenvectors A minus lambda I into xy is equal to 0 0. Same. I am putting the lambda is equal to 2 here. In this 2, 5 minus 2 is 3, 3 minus 2 is 1. So 3 3 1 1. 3 3 1 1 and xy is equal to 0 0. This means 3x plus 3y is equal to 0. That means x plus y is equal to 0. Second equation, x plus y is equal to 0. Same. So this is the equation. Suppose x is equal to k, y is equal to minus k. So x, y is equal to k into x is 1, y is minus 1. So k into 1 minus 1. So square root of minus 1, 1 plus 1 is square, minus 1 is square, is equal to 2. So divide it by root 2. So 1 by root 2 and minus 1 by root 2 is the normalized form of eigenvector. First 1 by root 2 and minus 1 by root 2. So the B is the correct answer. This is the question asked in 2012. Again, it is a question of consistency. So here again you are required to find out the rank of A and rank of K. So matrix A is this coefficient matrix A is 1 2 1 2 1 minus 1 1 2 1. If I reduce this, I will get 0 0 0, means C1 minus C3. So because both column are same, 2 1 minus 1 1 2 1. So rank definitely it is 0. This is equal to 0. If I take two row and 2 column, here you see 2 1 1 2. The determinant is 2 into 2, 4 minus 1. 4 minus 1 3 is, which is not 0. So rank of A is 2. Now I require to find out the rank of K. Means K is 1 2 1 2 1 minus 1 1 2 1 and 4 5 1. It is 4 5 1. So this is performing the column transformation. First element will becomes this 0. If I reduce this in this column means C3 minus C1, so it will be 0. So it is 1 2 1 2 1 minus 1 0 0 0 and 4 5 1. Now add C1. In C1 add C1 plus C3. 3 3 0 2 1 minus 1 0 0 0 4 5 1. So now you are required to find out the rank of 3 by 3 matrix from this. So I am taking this and this. So 3 3 0 2 1 minus 1 and 4 4 5 1. Find out I am finding out the determinant of this. Performing this R1 minus R2. This is equal to, it's a sign of equal. Okay, Control Z. This is equal 0 1 0 1 and minus 1 and 3 1 5 0 minus 1 1. This is equal to, if you add this row and this row, you will get 0 0 0 3 1 5 and 0 minus 1 1. So first row becomes 0. Now the rank will be, if I take this 3 into minus 1 minus 3 minus 0, so minus 3. So definitely rank of K is k is 2, which is equal to rank of A. So rank of A and K are same and it is equal to 2, and which is less than 3 means number of variables. So the rules say that if rank of A is equal to rank of K, which is less than the number of variables, then infinite number of solution. So you see here, infinite number of solutions. C is the correct answer. This is a 2013 question. The eigenvalues of a symmetric matrix are what? To find out the solution, you just take an example and get the eigenvalues of symmetric matrix. So I am taking this simple example 1 2. So lambda is equal to 1 minus lambda and 1 1 2 minus lambda is equal to 0. This means 1 minus lambda to 2 plus lambda square minus 3 lambda minus 1 is equal to 0. This means lambda square minus 3 lambda plus 1 is equal to 0. Lambda is equal to 3 plus minus 9 minus 4 divided by 2. This means this is a positive, this is positive, this is positive, so it is a positive. So what are the options? Real, complex, there is no, it is not a complex number, it is not a complex number, it's a real, so C is the correct answer.